Hi everyone. This is my review of my OnStep rebuild of my CGE Pro using Chad Gray's kit. Sells for $600, has all of the OnStep components, the steppers, these 3D printed cases, and overall, it's a pretty nice kit, and certainly if you don't have 3D printers like I do and all of the capabilities where I could have done this myself if I wanted to spend the time, this is the way to go. And so far, looks like things are going to work well. I'll be doing first light here this evening if the clouds move out of the way. And I just wanted to preface this video by saying, throughout this, you'll hear me making comments, and they may sound a little critical or nitpicky. It's not intended to denigrate or say anything about what Chad has done. He's done a fine job. But my job and what I do on a regular basis is all about continuous improvement and looking at things and saying how they could be improved. And so that's really what I'm doing here. Again, sometimes things like, well, it'd be nice not to have to go get this tool. That's not that big of a deal to go get the tool, but still, you could improve the product if I didn't have to go get the tool. So I just wanted to add this at the start. Hopefully, Chad, I expect he will probably watch this at some point, and hopefully he'll take some of the input as constructive criticism and come out with a better product for people who buy it in the future. Okay, so I'm finally fed up with rebuilding my CGE Pro mount due to the poor motors that Celestron put in them. The main problem I've been having is that, mainly on the RA motor, but I'm sure both of them are suffering similarly, the brushes, basically the motor overheats, the brushes melt the plastic housing that they're in, and then they're no longer making good contact. And so the motor will run sometimes in starts and stops and whatever, just because the brushes aren't making contact. And so I have decided to do a complete rebuild. I would have loved to have done this all from scratch on my own to be what I wanted it to be, but there is an open source solution for rebuilding mounts called OnStep, which is just putting stepper motors, kind of like what you would get in for a 3D printer, and using that approach to control the mount. And since I have been going through a lot of different things, I decided I really just want to get my imaging train up and running. So this is actually a brand new camera. I've had it for several months now and have yet to actually take a single picture with it, simply because I've had other observatory problems, between the wireless system that I had set up for opening my roof that failed on me and had to be reprogrammed, to the mount not working, and the floods in Central Texas, and you name it. I just decided, well, I don't have time for another hobby project, no matter how fun it is. So I decided to buy a kit that sold online for $600 that contains all of the components, and the guy who's designed the kit has actually built housings that are similar to the Celestron housings that I'll be removing. And hopefully this will be something that I can install relatively quickly and get up and running. So I'm essentially starting from scratch, and we will get this thing going and see what happens. So I will put the link in the description below, but this is Gray Digital Arts. Trying to remember his first name, but Mr. Gray's the guy who did this. And let's see what we've got. So a little bit of packing material, assuming this is just more packing material. His printed manual for adjusting the motor mount brackets. And we get into the first parts, which are the drive cables to go between his drive box and the two motor boxes. What he has is one pair that is, this is mostly just the digital lines for the limit switches, and then this is the motor power for the right ascension. And then he has on the declination, I think he's got the motor, well, actually, it only has 4 pins too, so not, oh, that's the same one. That would be why. He's down to 2 connectors, so this is a little different than what he had shown on his website, so we'll see when we go to start putting it up, but yeah, looks like we've got quite a few connectors there. Okay, in this package we have the 3D printed lids for his 2 boxes, and not bad looking. See a little bit of loose stuff, so this is the overhung part. I'm kind of curious how he's doing that, because normally when you're dealing with something like this, you could print it vertical like this and actually get something that would come out okay, or probably use this side, the longer side, and you could come up and print the whole thing that way. This kind of looks like it's being done in 2 parts. I don't know if he's welding those together, gluing them together. That's what it kind of looks like. And sorry, let's try to get some light on the subject. There we go, that's much better. Yeah, it's relatively dark in the observatory. You don't normally need it all that bright. So I'm not going to start this over, but yeah, looking at that edge, I think what he's doing is he's printing 2 different halves. He's printing the solid piece facing like this with these parts just bridging, so you end up with, you know, a little bit of stuff on the inside, and then I think he's printing the perimeter and just gluing those 2 parts together. Alright, here's actually the main reason that I went with this kit, beyond just not having time to do it, is he is getting the motor mounts machined out of metal now. I do have my own milling machine, so I could have gone ahead and done this if I really wanted to spend the time, just like I would have had to design all of his parts. And there's of course some gears, the pulleys for the motors, some belts, and a few, looks like a few more printed parts. These, I'm assuming, are the motors. Stepper Online, they're a common company for buying this stuff from, and you probably go look up what they run. The funny thing is, this packaging, this number, it looks like this was bought from Amazon as opposed to directly from Stepper Online, because that's a typical Amazon label that I'm very familiar with. Then we start digging down in. These are the 2 housings, it looks like. It's fun doing single-handed. And he's actually done, pre-wired everything, pre-attached the parts, which is nice, because in his early designs, you know, he was just showing the pieces and he had all of the parts separate. The one thing he had, which I was like, I wonder if we'll see this or not, is in one of his prototypes, he'd actually put the OnStep logo in here, which I'm sure was a lot of trouble, although the way he's doing it, he may have printed the 2 parts separately and glued it just like he's doing this. You can actually see the glue around here. So he's got these 2 parts. This one, if I had to guess, is for the declination axis. Although, actually, they look like they're wired. Well, no, they aren't wired the same. This one does have the D7. So, this one should be the RA axis. And so, basically, we'll be plugging the limits in there. This goes to a stepper motor. And I think I am going to probably leave most of the rest of this down in here because this is his little hand controller unit. So 3D printed box with, I believe he's just buying the circuit board off the shelf from somebody else. The interesting thing is, unless he's got the parts elsewhere, he was showing he had designed a battery holder here where you could use this thing wirelessly versus wired, but it doesn't look like he's providing that. So probably just decided nobody was using it, didn't work very well, whatever. And then here's his control box. Now, I'm a little disturbed that there are parts moving around inside. And now they've quit. So did it fall out? I didn't see it. If it did, I'll have to go back and check the video. But I may have to go in and look in this. The thing is, so this is, looks like it's a smaller box. Again, glued together, but in his earlier designs that he has his videos based on, all of the parts, he had a vent on this for one thing, so the vent's no longer here. What's shown in his original, and it looks like everything's coming in just through the board interface here. So, and let's see, so this is, he's printing this like this, but apparently without a top, and then he comes back and prints the top and glues it together. All right. So most of his instructions are actually directing you back towards his YouTube videos. I would have appreciated a full set of instructions, just because, especially since I'm taking a video, I don't really have time to refer back to his videos, and when you're on site like this, that's not the most useful thing. I had already reviewed them, so, and I've taken this mount apart so many times, it's not like I don't know how to get into it. The one warning he has is removing the telescope and counterweight, since you're going to essentially have the thing completely freewheeling. Now, last time, before I just changed some stuff, so my balance is probably a little bit off, but I was perfectly balanced for a while. I think I'm going to take advantage of the imbalance and just use a trick that's called a rope or a bungee to hold it against gravity where I want it, but I'm not really willing to come pulling everything apart. And so basically what he has, and we'll see this as we assemble it, is you're taking out the existing Celestron motor that comes through that hole. You're putting this pulley on, and you're putting his adapter to be able to mount the motor a little further away, and so you're going to drive with a small, and so we'll see this as we start putting it together. But he's not really giving a step-by-step, do this first, do this second, so it's pretty much just start putting things together, and then he's showing mounting the box towards the end. So, all right, let us start taking some parts off the existing Celestron, and I'll come back. All right, so after loosening my knobs on the side here, you can see that I'm still a little bottom heavy on the counterweights, which is because I switched to the smaller tube up there. But this is fine, because what this will let me do is, if I want to hold it in a given position, I can just hook this up to my rafter and hold it wherever I want it to be. Now, my previous videos where I've repaired this thing repeatedly, I've shown you how to get in there, but I'll go ahead and spend some time doing that. But the one thing that I'm going to have to do just to get access to this, I have to remove these two knobs anyway. So initially, until it comes time to take the actually take the gear loose to be able to swap the pulley, I can just go ahead and clamp the upper side, basically turn it where I want it out of my way, clamp those two knobs, and it will hold. Not exactly sure what's popping. Uh-oh. My mount is coming loose. That's not good. Good to discover that now. Just being held by the power cord. So I was a little worried about this, since this is the first time I've actually had this with this much weight on it. And so apparently my 3D print is probably spread under the heat a little bit. So got to fix that first. Okay, well now we see what the problem is, since I tried to reclamp it. Wasn't just that it bowed, but it actually ended up cracking on me. So previously, when I was using this mount, I had it on the Vixen rail over on the other telescope. So this is the first time I've actually tried to clamp, and I over clamped this. It's the same design I've used repeatedly. I've never had a problem with it breaking on me, but it could have been just an issue with the particular print I did too. So I think I'll go back and redesign this, make the thing wider, but given the way it failed, I need to go back and look at, I'll probably break this open, see what the print looks like inside, and see what I need to do to fix that. So, another project. Okay, so this thing broke all the way across, and you can see I obviously had a pretty low infill when I printed this. I'm not sure. I have a new printer. It's not that new now, but since I've been doing some of these parts, it's been new. And so the settings aren't quite what I used to do when I developed some, what I considered really reliable. So definitely need to reprint that part. The other part is printed in a different orientation, so the structure runs this way. So it's a lot tougher in that axis, but I may still redesign that as well. The other thing I wanted to show is just how massive, by the time you get the 0.8 focal reducer and the necessary spacing out, and then this heavy camera on there, all of the weight is here. And you're mounting this thing up here. So the factory mount on this was worthless. It bent just out of the box with putting anything on it. So I designed this. It's nice, like I say, it's solid, but unfortunately had a weakness there in the design. So I'll come back and fix that. I may also, just because I can't support it back here because this part all has to move, but I could make it extend out past the knobs, just to give, it really will only be the transfer to the rail, so it's not, making it longer won't do a whole lot, but it will give a little more to something like this. I think in this case it's just, I can clamp it so tight with these nuts that I just clamped till I broke it. Alright, so now that I've averted that near a disaster of having my new camera and OTA crash to the floor, saved by the power supply cord, locking power supply cord, which I strongly recommend, and one of the things that I was hoping this new unit would have, but it doesn't. But we're going to start by going ahead and just disconnecting the Celestron electronics. And these are always a bit of a challenge. Okay, and you can see the number of pins we had here for the servo motor and the various limit switches and the encoder feedback. So the reality is he probably could have just adapted this, take that connector off and use it, but then the end user would have to be wiring things up. And we'll have the same thing here. And at this point, since the body electronics are never going to be used again, so we believe, we can take all of these cables off completely. And again, all this whole housing is going to come off, so it's not like I really need to cap this stuff. Go ahead and come over here. We're never going to power up this again. And just have to see if this will reach when I get that new setup on here. Probably will when I rearrange stuff. Oh, and time to try to clean the dust out of this yet again. Unfortunately, where I'm at, I have of course I have a gravel driveway, but that's not the real culprit. I have a cul-de-sac road it's beyond the trees, so the trees help reduce the dust, but I still get a tremendous amount of dust infiltration in here. And there's not a lot I can do about it, especially not when the roof's off. Okay, so here's my first problem with his kit. I think I showed earlier the picture, but he's designed it to mount with these two screws that basically mount the mounting base to this center electronics column and then the top to that. And before I bought this, I bought this used, but the guy had already done a set of ADM upgrades to make it so that you had hand control, you just had hand knobs for assembling your scope out in the field. And unfortunately, that means that these are probably going to be in the way of his opening on that box. So I will have to do something different. I don't know, I may still have the screw somewhere, and it's not like I ever tear this down, but probably I'll just double stick tape the thing or hot glue it right there, but we'll see. But yeah, that's the first thing that I see that I'm gonna have to do something about. Now, like I said, I've shown taking this off before, but we'll start here. You'll notice this is a Phillips, so the lids for both of these boxes use Phillips screws, and you take the lid off, and then you have to get back here and take all of these screws out with an Allen wrench. All right, so here's the part that may actually force me to go ahead and take off the OTA. For getting this cover off, you just basically wobble the RA back and forth to clear the screws so that you can get them out. But when you get up here, you've got these screws that the OTA is getting in the way. And there's really this one, I have a stubby that I was trying, but unfortunately it is too big of a tip. I probably have another one around that would work. And I believe I have taken this off before without taking the OTA off, but I will probably go ahead and do it because then I'll get to clean everything thoroughly yet again. It's just, I've got my bundle primarily of power cables for most of this. So it's the power for the laptop, the power for all the cameras and other components, the USB ports, you name it. The only control cable now, presumably I'll be able to even not have a USB going to this because this is supposed to have Wi-Fi capability. And so I'll be able to lose the USB that's currently going to control the mount, and the one thick cable that's in here is actually, I do have a network cable because I didn't want to use Wi-Fi. And so I have this network cable going back that, and by the way, if you're curious about the tape, that's to cover all the blue lights so that we can't see them coming off the laptop. So I probably will take this off unfortunately, I've got a conference call with China I've got to go get ready for, so I'm probably just going to stop for now versus trying to get this all taken off. But we will see. Okay, so giving up on my desire to get everything up and running as soon as possible, I went ahead and disconnected all my cable bundle. Here's all the different power cables, and this will also let me get rid of the unnecessary cables. And I've been needing to do a clean redo of all of this since I keep changing stuff. So this will give me a chance to do everything clean. Of course, looking at it, I was thinking, what I'd love to do is bring up one power supply for 12 volt here that then branch to everything. But the reality is I'm actually, for the cameras, and the mount, I go all the way back to the power supply so that they are not running parallel. They've got their own set of power and don't have any risk of a brownout from one affecting the others. So with that, now I can go ahead and pull the OTA off and cleaned up over in the corner so that I can store it over there, and then we can get back to the disassembly. One downside to Losmandy rails over the Vixen, frankly, is just they make really lousy handles. So on my other scope where I've got a Vixen rail up here, it's great to be able to just grab it and be able to hold on to something, but that big Losmandy rail just doesn't make a handle. There's no space between it and the tube to reach underneath, so getting that beast off is a little bit of a challenge. But here we are now, removed, with a nice layer of dust underneath. And now we just pull the counterweights off, and we can go ahead and do this as recommended with nothing permanently attached. And then we'll have to build the whole thing up once we get it going. But that's a task for either later this evening or tomorrow or the next day. And since I can't leave well enough alone and stop when I say I'm going to, basically still have to take these two knobs out to get clearance. But now you can pull the screws, two of which, like I said, go back into this back housing, which is why you have to get this cover off to get the rest of it. And you can see the difference. Here's the original Celestron encoder on the Pittman gear motor. And you can tell potentially, first off, by the fact that it's thicker, this is the US something. I forget the brand that I bought. Probably see it though. USA Digital, or US Digital. So that's the encoder that I bought to replace the one that I scratched the first time I repaired this motor. And that worked perfectly. I had to wire up a new set of connector for it. But the one challenge is, you notice there's a little bit of space there. There is no space there. So in order to get this in here, I was always having to take this part partially loose anyway. And of course, you'll see later we're going to take this thing off to be able to get to this gear. So with that, now I do have to go and come back and finish taking this apart later, and then I can start putting the new parts on. Okay, so now that we have the covers off, we can start disassembling in this case, pull this bottom nice cast aluminum piece that we're going to toss by removing each of these screws. So basically just this takes a 2.5 millimeter Allen wrench. The guy selling the kit does have some screwdrivers with a hex tip on them, but he was out of stock. I might have actually bought a pair just for the heck of it, although I have plenty of Allen wrenches. So, and frankly, it's nice to actually have the ability to torque it with the right angle, and then you just come in with the ball end, like so. Sorry. And do that. So I'm going to get all of these pulled off, and we'll pull these housings off of both the top and bottom. Now, once you pull all the screws, you've got the housing hanging here loose, and there's two pieces. One is the motor and encoder drive, all going to this control board. The other, you'll notice the control board has some additional sockets. That's because they're going to be the same between both axes, but you only have the one limit switch up here for the deck axis. And so go ahead and unplug both of those. They've got a little bit of a retention, but they just pop right off. And then we'll pull the motor. It's a good idea to have something to put all your screws in that you don't lose them, since unless he set replacement screws, we'll probably be using those to put his new housing back on. I would like to get new screws, we'll see, just because some of these are rusted. They've been on and off a lot on the RA axis, so they could stand to be replaced, but anyway. And by the way, these two little dimples in the bottoms of these housings, which he's had to replicate in his housing, are simply for those two bolts that stick out the bottom that hold this whole gear assembly onto this adapter. So it's a little right angle adapter. I'm not totally sure why Celestron couldn't have recessed those, because that's a real pain to have that extra part, but that's why that's there. And these screws on the back side of this are really the pain, require me to basically be able to reach in through the mount. I've already got this one loose, but the ball end here is actually very helpful for that, except for this one, which is one of the reasons why I would like new screws, is because this one's kind of stripped out. I managed to break it loose again, but it actually slips when I'm trying to use the ball end to unscrew it. So I will finish getting these, but yes, it's kind of fun reaching my hand in from here to try to get to those screws. All right, so now that we're in this, you can see that we've got three different connections here. We've got the two limits for RA, so these serve as home and right and left limits. And then you have this little board here, which has an optical sensor, and you see that slit. That is the index mark for the right ascension axis, and that is used when you perform correction for the helical bearing correction. I forget what the name of it is. It'll come to me after I'm done recording this. But basically that gives you an index mark so that if you do your calibration for how much error there is in the bearing, or not the bearing, but in the gear, then that's how it goes back and finds that, is by finding that index mark. I would assume, since he's got the support for it, that this is actually supported in the OnStep firmware, but I haven't ever looked that deeply, and frankly, I never use it. So, okay, so we now have the two housings removed, and went ahead and screwed the bottom screws back in, but the top are loose because they actually screw into this. So now we're ready to start taking motors off. And the first step is to take those two set screws out so that you can take the first gear off. And the good news is this axis looks like it's easy to access. The one that he talks about that you have a challenge is getting past this block on this unit. We will see just how bad it gets. And of course I've had this one off repeatedly, so I don't expect that to be a major issue. But we will see whether or not those set screws are a problem. So that has the first two spur gears off. You need a 1.5 millimeter Allen wrench to remove the set screws, and it's helpful to actually have a screwdriver to be able to pry this off. The one that I put on and off repeatedly is actually very hard to get to come off the shaft, versus the other one that slid right off. I think that's as much binding up against the upper gear as anything. I had adjusted this to be as tight as I could get it last time, just to minimize the slop. So removing the gear motors here, we're back to taking out Phillips screws that you've got 3 that hold the gearbox on. And even on this, I was barely able to get it out past this. And this is the part where I talked about that on this one, I've had to remove it to be able to get this out past it, or get this in. Now, the fact that I kind of don't really care too much if I mess this up, I might be able to just yank it out, but probably won't try. But the issue is, all of these screws that you see, you don't want to touch these. These are all your tension screws that are pushing this plate against that plate, against other plates. And so what I'm typically doing is I'm typically removing these 2 screws when I needed to get in and do it, because these will tighten back up and you'll get the same tension back. Now, in order to get this off and get the other larger pulley on, the directions talk about the need to actually loosen these up in order for this whole block to come loose. I think I'm going to have to do both on the lower, because I don't think even when I loosen this up, this takes the block off the gear here, off the worm gear. And so I don't really, that won't help me as far as getting the motor out on the other one. So 2 steps for that, and then we come along and take that off and start putting new parts on. So let me get this motor out, get this stuff kind of organized a little bit, and then we'll be very close to putting the new parts on. Now, the one thing that he talks about in the videos is basically checking your tension here. Now, on this, and I've never been happy about this drive, you can tell here, and you might be able to see how this is jumping? What's happening there is, here I'm pushing against the weight. And so I have a nice tight behavior, and it works fine. But when I go the other way, it loosens up and it falls, right? And so this causes a lot of the chattering that you get in these mounts. It's really nothing to do with the motor or anything else. It's the fact that as you're moving away, you're not pulling it or you're not pushing it. You are loosening, and then this drops. You loosen it and it drops. You loosen it, it drops. And so I don't know whether it's worth playing with the tension, whether that would make any difference to this. The trick is to, and these aren't tight enough, but if you were to sit here with enough out of balance, basically. So you're relying on being out of balance and making it so that now I'm pulling it, and when I release, I still get some of that. I don't have enough, so I still get it bouncing going one direction. The main thing is to make sure that it's balanced in such a way that when you're tracking to the west, it's tight. So I may do some investigation before I finish, just to see if there is a way to improve that at all versus getting a different mount. All right, so after removing this screw completely and loosening that, I'm able to tilt this enough and get that motor out. But I decided to go ahead and show you just how you can see how this whole assembly, the spring that's underneath this, is controlling just how much tension this is putting up against there. So this may be a situation where I do need to try adjusting this. And what you have is you have a pull screw, a spring with a tensioner on it, and then a stop to prevent you from going any further. And so that's that mechanism. It's kind of the same on all of these in various variants, but anyway, I'll tighten the two. The nice thing is these are actually flat heads with a shank on them so that it pulls up square when you tighten it. All right, so now I have both of those gears off. They do take a 2mm instead of the 1.5, so a slightly bigger Allen wrench. And getting them off by themselves was not possible. They do have apparently Loctite on the threads as well as just being tight. But my trusty Harbor Freight Chicago heat gun, and there we have it. So now we are essentially fully disassembled, and I get to start seeing what it takes to get the motors and stuff mounted from the kit. So we will start that process and see. The first thing I'm going to do is go ahead and get the large pulley out and just see what happens when I try to get it on the shaft, or is it blocked like he suggested it would be. The existing tooth gears came off just fine, so we will see. Getting into our bag of parts, we have the pulley for the large side, and we have these adapters, which this machine part was really the main reason that I got this. In his original design, he had tried using a 3D printed part. Problem is your stepper motors get warm, so that's not ideal. However, the thing I'm very disappointed about is that rather than taking the additional machining step of putting tapped holes in here so that you would just screw this from the other side, he's got lock nuts. So, you know, that's disappointing, because that for what you're paying for it, they should have taken that extra step. It's not that it won't work, it's just, you know, that's the difference. That's the difference between an exceptional product and just something okay. So hopefully he'll take that as feedback and change that in the future, because yeah, that's pretty disappointing to me. But we are going to have to go through the process of pulling the shaft back, because as you can see, there's just no way to get this big thing on there. It is going to fit, but just barely, right? This is the type of clearance we're talking about. So the fact that it's possible to do this retrofit at all is just bare luck, without having to have either machine these down to make them thinner, or find a different part, right? Do a smaller pulley and probably have to go through a double gear reduction. That's the thing that I questioned about using a stepper motor on this to begin with, is that this thing is going to be driven with only, I haven't actually counted, but it looks like about maybe a 4-to-1 reduction on the pulleys that he's got. And so, that doesn't give the motor a whole lot of torque without additional gear reduction. But, well, we will start loosening things up and see how much effort it takes to get this on. All right, so here we are now with the pulley slipped on, and you can see the type of clearance that you're having to work with here. And you want to make sure that there's enough of a gap. And I may actually pull this back off and wipe some of that grease out of the way, because I don't really want that on my pulley. But you want it pretty close to that bushing so that you've got clearance there, and more importantly that you've got enough to be able to get the belt on. Otherwise you would need to slide the belt on and just leave it on there as you're putting it on, which probably isn't a bad idea. This is now loose, and if you plan ahead, you can use the hard stops on this axis to hold it pretty much out of the way while you're working on it. So you've got a 5mm for taking off or loosening these 3 screws, the one up in there and the other 2, and then it's a 2.5mm for the set screws that come on this wheel. So I'm going to clean up that grease a little bit before I finish putting this together, and go ahead and do this, and then we get to do the same to the other axis. Okay, so here we are with all 3 of these screws on the bottom tightened back up, and now it feels a little stiffer, but it's really not, because I got the same problem. I can still feel, you can see the jumping versus going the other way where I've got a little bit of pressure on it. So before I do anything else, I am going to try adjusting the tension here just to see if I can pull it up just tight enough to take care of that. Of course, the other thing I really should be doing here, since I bothered to tear into it this far, but that would be a much bigger thing, would be to re-grease this whole worm gear. One way of at least doing it in this configuration would be just to get a solvent rag and run it through the entire cycle, wiping off the grease as it comes on, and then put fresh grease on. It's funny, you can still see some of the blue of the original grease versus the black for everything that's been running in. Blue or green or whatever color it is. Anyway, at this point, like I said, I'm going to try tensioning it before I do anything else, and then we'll go from there. Okay, so we will see if the stepper motor has trouble driving it. It is tighter than it was, and certainly now don't have any jumping. Essentially what I ended up doing, so initially I was trying to just tighten the spring, which this is one of those really Losmandy things, because a big screwdriver that would fit the slot size won't fit. A mid-size screwdriver won't fit. Actually, I had to go down to this little guy. The good news is there's very little tension on that at all, so even with that little screwdriver, there's no problem adjusting the tension on that screw. Initially, like I say, I tried turning it in, quarter turn and half turn, and it wasn't making any difference. And that's just because this blocker is preventing it from getting any tighter. So the spring itself was not putting any pressure on it. I took this off less than a quarter of a turn, and it was way too tight. I tightened it back up almost to where it is, but it's now letting the spring actually do something, and I actually backed the spring off. So if you look there, you can see that thing's actually out. At least, not sure if I ended up with half a turn there or a full turn by the time I was done. I'll have to go back and look at the pictures that I took before and after, just to compare. But like I say, now there's certainly no chatter, but it does take a reasonable amount of effort to get this to move. So we're kind of in the middle. I probably still need to adjust. I'm just not sure about reducing the tension versus just putting that block. Problem is this thing, first off, the screw doesn't actually, it's not like it's that fine of a pitch screw. And so just a little bit here does a lot, and a little bit of thermal variation does a lot. So, again, it's kind of, it's not an uncommon approach. It's just not a good approach either. All right, so have the pulley on the other axis. This one definitely turns easier, and the difference being largely that there's not any sort of offset load on this, but I think this thing just meshes better. So here I'll investigate a little more. The other thing I am a little concerned about, just in terms of remeshing this, is that unlike these two screws that are nice because they will recenter well, loosening the 3 screws to take this off, there's quite a bit of play in that when those are loose. And it looks like there is a washer under there that hopefully helps center it a little bit. But the reality is, I can't be guaranteed that you get this black block back where it was exactly. And that could have shifted the gear essentially up and down, especially in this orientation where, I'm kind of fighting gravity. This thing's just up here light and floating. But I'll continue to tweak it until I'm happy, but I really want to get rid of that chatter, because that's been a long-standing problem for me, and I think if I've got it adjusted where I still have that, I'm still going to have trouble. Okay, so I have my little adapter plates installed, and basically you need the 2mm Allen wrench for the backside and a 5.5mm socket or wrench or whatever for the nut. Commenting on these, the one thing I'll grant is that at least they are locking nuts with the little plastic piece in there so that they shouldn't work loose. Not that I would be really worried about that. But it is a situation where these are now the only nuts in this entire product, right? Everything else is tapped and threaded, and even if they were going to use the nut, the aggravating part was having to go get another tool. I had to go get something to now deal with nuts. But there are other ways that this could have been handled. For example, these screws that, of course, you have to hold, you could, ideally, you do a hex opening here and just drop the nuts in. That's hard for something this small to machine because it would require a really small cutter. But you could slot this, and you could still put the nut in there, and the slot would hold it square so that you could then just screw the screw in from the other side. They would have had to deal with the recesses and making sure that, the screw wasn't so long that it came out too far. But, there are ways, without adding a lot of cost, to have eliminated at least the need for the other tool. But it is what it is. It's installed. And now we get to deal with the other part, which is the motor mounts here, but only 3 of these screws are accessible. They've got the hole for the last one, but there's no way to get to it because of the existing mount. And this one's barely accessible. The only thing, there's some comments about whether or not you can actually get even this one in without possibly having to loosen this back up so that I could just get the screw head in. But we'll stick it in and see what happens. All right, so I got both brackets done, and as I feared, I did have to take them loose to put this screw in. And with my luck, having this up here and trying to deal with 3 screws plus this, I end up, as I had feared when initially putting it together, if I had put that in there, was ended up 2 screws on the floor, one of which I found, one of which who the heck knows where it went. Could have gone down into the drain there, where my cable routing for large cables is. I stuck the vacuum down there, didn't suck anything up, so if it's down there, it's way down. Or it's just off at the edge, because when something hits this concrete, it flies. So luckily I had some additional screws. It looks like there may be 1 or 2 extras in what he has, but I haven't actually gone through and checked. Doesn't look like he put extras of everything though. And you know, again, for the few pennies that screws cost and the price of the kit, having a nice set of extras for cases like this, which are quite common, would be nice. Now, the other thing I wanted to talk about, so here's the motor mounted, and we'll put the pulley on, and basically that's your tension adjustment for the belt. So the thing is, let me clamp this tight just so we can see it. So the one thing about this bracket, you'll notice that there's still a lot of room that's going to be in this case to clear all of this stuff. So while the top you're going to want to have flush for clearance up here, the reality is there's absolutely no reason this motor had to be in line with this. So a lot of the problems as far as the screw locations and stuff, it's just very linear thinking. This bracket could have been made, because you see that it extends on the bottom side anyway, it could have been made to come down here, the motor could have come in here, and it doesn't have to go in square either, right? That motor could mount like this, and you know, your screw positions would be different, obviously moved down, right? So if I moved it like right there, I'd still could make the slot move back and forth in whatever direction I need, regardless of how I rotated the motor to get all 4 screws exposed. So again, we'll see if he takes any of this as feedback versus criticism. But again, there are ways to have done this that you would be able to put all 4 screws in. Not that you absolutely need them. 3 will be enough, but just thought I would share that. All right, so now lining those up as best as possible. It causes a lot of flare there, but basically it's easy for me to sight down this one. The bottom one was a little harder sighting up from the bottom. You could also just put the belt on there and kind of use it as your guide. And keeping this relatively snugged up so that, you know, it doesn't come in when you clamp it. And remembering, again, you got a flat, so you need to put one of the set screws on the flat and then the other one, and tighten them both up. Everything, all of these screws, everything here is all 2mm Allen wrench. The other thing I was going to comment on, these I believe are the 2 amp. That's what they're supposed to be, is my understanding. NEMA 17s. This is $14 on Amazon. The 1.5 amp is $8. So that just gives you an idea of what those are running. Probably all of the hardware together is less than $100, I suspect. Electronics, probably a little more. A lot of effort going into putting all the cables together and things like that, because it's all customized. The one question that I have on having a 2 amp motor is more power if you have the power to feed it. The fact that this is going to run off of a 12 volt supply, normally when you see these in a 3D printer, you've got 24, 48 volts so that you can really drive these with a sharp curve, especially as you go to higher frequencies. You've got to put more voltage on it to be able to get the current to flow through it. And so I do question whether or not the 2 amp is really doing much for you versus 1.5, just because of the fact that 12 volts, you're never going to get 2 amps through it, especially with the typical supply, if you're using something like the wall wart type Celestrons, it won't give you more than 2 amps total. So, but anyway. So the next thing is simply to put the belt on. I was going to try to do that live. Had it in my hand and then stopped recording anyway. May have to get both hands just to get past this little edge. Come on, get on there. There we go. Trying again to avoid getting it all greasy. And now, sliding this up, the question becomes, do I have to actually take this off to even be able to get it to slide in? If I don't have enough forward motion to get it on without stretching the belt, the only other way is to actually slip it on and slide this whole thing on. But I need 2 hands, so. All right, you can just barely get it over the stepper there. Without having to take this off, but it was very tight. Kind of had to roll it around to get it to go on. But there you are. Need to tighten it up and do the same on the other one. And want to make sure that it's tight enough that it doesn't skip teeth, but not so tight that it ruins the belt. Okay, so here we are with the belts done for both assemblies. Tension and get an idea, just a little bit of give. Now we get to start putting the electronics box and hooking pieces up here, and then we figure out how we're going to mount the controller down here and go on to the next steps. Okay, so comparing his board design and the one little picture that's in the instructions on the electrical connections for the switches, this, which is again your RA reference connector, this has power, ground, and sensor lines. And what he shows in his picture was a discrete, kind of like this, where you had the wires and they were color coded. Unfortunately, that's not what Celestron does anymore. So now I'm back to having to pull out my meter and going back to the Celestron board here. And on these, the tab on the motor driver, the tab on the regulator there, as well as actually the shield, those are all ground. And so I can test, and so the right hand pin on the 2 limit switches are the ground on that, as well as the right hand pin there, which means that if I come to this cable, and you see how this has the tab here, so that this cable goes onto that board like this, meaning this pin on the right hand side, as we're looking at it from the top, has to be ground. Coming up to this board, I can't really get to anything that I can definitively say is ground on there. And so the best I could do would be to use the other board. So with that, that should give me what I need, though, to be able to hook this up properly. And so if we look at this, ground is on that side. It's not a latching pin, but I should be able to slip that on, and then hopefully there will still be room to get the other 2 pins on there. It'd be nice to have the latching mechanism that this uses, but we'll put the connections on and see what happens. All right, so that was pretty tight getting this cable in. I had to very carefully bend it sharply at a right angle to avoid pulling the wires out of the crimps, but that should have this assembly able to run. I'll have to arrange all these wires when it comes time to close this up, but I don't really want to go bolting things on right this second. I might put a screw or two in the side of it, just because I may still be adjusting this, but I think I can probably do that. Not really. So, but I may go ahead and put a screw there just to hold it. All right, time to do this assembly. So slipping this housing into place and going ahead and putting one screw in, those orange knobs on the back actually were kind of tight going on to those screws. So I'm not sure, putting my finger in the other one, they seem to be the same diameter as in the original here, but what those are for those two nuts, which those actually float. See how that moves? That's the, these are floating for the tension on the gear, so there needs to be clearance to this. I'm not sure why that felt tight putting that on, but hopefully that won't cause any problems as far as the floating mechanism here for the drive. Okay, so here's what I've decided as far as mounting this controller box. I think I'm going to go for right there. Basically, that will put all of the control cables out this same side to where they need to go, and actually keep my Wi-Fi, which didn't really need to poke a hole for that, but pointed over toward my router. And what I'm going to do is I've got some of this really neat stuff. I'm going to have to buy some more of this because I use it for a lot of stuff where I want to put something up, but I don't want it permanent and don't want to damage the surface. It's basically a silicone material that's very, very sticky. It's a gel, basically. And so you can put that on, and it actually holds pretty well. I've got a bunch of, in my outdoor kitchen, I've got some metal signs for decoration, and I've got them stuck up to the tile with that. And I've only had like one sign that didn't want to stick, and I think it was just too close to the grill. So that's pretty neat, and I'll just put a couple strips on this. The one thing I noticed that's different from what's in his videos and pictures, originally, of course, it was a bigger box, but he had screws, I think, both top and bottom. Now he's just got a bump for it that would have blocked that. But even that doesn't line up, so I don't know for sure what the idea was. This would really only go under the top screw if I put the normal screw back in. Sorry. So that would really, if I put it up there, it's above this, so I don't know for sure why he's got the bump there, unless it's just part of the support inside or something. Okay, and here we are now. I decided to go vertical rather than across, but with two strips of that gel tape adhered nicely. Now I got to peel the plastic layer off and just stick it right there. It slides around real well without the gel on there. So need two hands, so I'll pop. And now with the protective plastic removed, I just have to very carefully get it lined up exactly where I want it, because I don't think I'm going to be able to move it much. And like I said, that has a lot of cushion to it, so you just basically push it into place. And now yanking on it. The other thing I had debated was I've got some heavy-duty outdoor Velcro I could have used, but the downside to that is that the glue would actually adhere solidly to the paint and potentially take off the paint if I ever wanted to pull it off. So this stuff, worst case, if I can't actually manage to get this loose, you go with a piece of wire and you just pull it down through and shear it and then take the goop off. It's kind of similar, not exactly the same, but similar to the type of glue that, for example, when you get a credit card and it's glued to the piece of paper. It's kind of like that, but nice and clear, so you don't want to leave it exposed anywhere that you would be touching it because it's sticky, but it actually does a very nice job. Okay, so next we make our cable connections. The one thing, this brings the power now to the opposite side of the mount. I'm not sure the power switch is worth anything in my case. Again, this is the one, I realize he's got a circuit board in here and this is just on the circuit board, but they do make circuit board mount with bulkhead attachments where this could be a locking connector here. And I really do prefer having the, if I can grab one, this style of locking connector, right? And so that's essentially what I have powering everything, is that sort of connector. And of course that's what what this guy had, right? The DC inlet was a locking connector. So that is a bit of a downgrade without that, but the advantage here is, again, I'm in the observatory. I'm not planning on taking this on the road. You never know. But the chance of tripping over a cable, especially since this is my photography rig, is pretty slim. But, all right, cable connections time. Okay, so wiring up the two axes are pretty much foolproof. And he's got these pretty nicely bundled. You've got on this, the 4-pin is your motor and the others are 2-pin, so you can't possibly get them reversed even though they're same size. Connectors are keyed, so they can only go in one way. Don't try to force them. And then here you've got the D sub because you got more digital control pins and still a 4-pin motor cable. One nice thing here is, at least because they're new and young, these connectors go on a heck of a lot easier than the old Celestron ones. I was never having to take it apart, so it didn't really matter too much, but man, those things were a pain. I did go ahead and put the screws in to this, and apparently either Chad's version didn't have the screws or he decided he didn't like putting those screws in across the bottom either because he didn't put any holes for them. So these only get held by the 4 screws on the side, so 2 on each side, and then the screw on the top from the lid will brace to this. Okay, with that, what I don't know is which way is the power switch on this thing. We'll leave it in that state and say, Alexa, turn on the telescopes. And I can't tell if that's a little red pilot light, but I do believe it is. Camera lights showing up a little too much. But let's see what we've got here. Looking for OnStep. So I think this thing has to boot. There we go. Connection okay. It's got RA and deck number that are probably completely nonsensical, but what we really care about is can we make this thing move? And I have no idea what any of these buttons do. Guide slower, guide faster. Max. So, does any of this move anything? Which you can see here. Probably should turn the light off. SLUT. Okay, so it powers up, and we know everything's connected, but I got to figure out how you get into the menus and what this is. I would have thought that this would have arrived essentially set up for this and ready to go, so that we plug it in, turn it on, and it does something. There we go. So if we turn on tracking, I have to hold it to turn it on. Settings. Is it the right button? Start. Parking. Unpark. Still no motor motion. So either I don't know how to do it, even though this certainly looks like this would be the motion control. You'll recall, and I debated whether to get into this, hopefully if whatever bounced around inside this hopefully is down at the bottom, but it could actually be one of the circuit boards came off, because this thing is a motherboard and daughter board, but it could also be jammed in there, who knows how. Could be one of the motor drivers for that matter. So I'll do a little research and see if I'm missing something about how this is supposed to run, but this is not promising. Well, best laid plans and all of that. It's time to see what's inside this and whether or not something's damaged. Basically, I've pulled the 6 screws, had to pull off the knob from the ADM adaptation here. Okay. Driver boards appear to be in place. And unfortunately, this cover so it would appear that this thing is screwed together and then glued together, as best I can tell. Unless there's an adapter plate that slides out. Whoops, it's not going to work very well for you guys. Okay, I'm going to have to dig. I don't want to take this thing back off the mount since I used some of the last of my tape to get it up there. Can't tell. There may be a screw at the back that's loose. think I see a screw on the bottom. Maybe just this one screw that's actually holding the board into the box. So I'm going to try pulling that one. I've been emailing Chad this morning, but he didn't actually say one way or the other. Fuse isn't blown. But, all right, let me see if I pull that screw, if this will come out. Well, so there's your culprit. This is the one screw that holds the board in, and that's the nut that came and fell out when I slid the board out, and that's where the nut came from. So, unfortunately, that nut was loose, and that's what was bouncing around. Now, the question will be, if I fire this all back up, all the drivers seem seated. Don't see any blown up circuitry. But, like I say, unfortunately, I wasn't able to get this to move yesterday. But we will see what happens. So one of the clear signs of a homemade board is all the flux still around all of the soldering. And don't have a nut driver handy that fits that. I'm going to just have to probably use a pair of needle nose and tighten that nut. But we will put this back in, see if I can get it running or not. Okay, well, the good news is it is actually moving now. You do have to turn on tracking in the menu, which I had tried and didn't get anything. This time when I turned tracking on, you could actually hear the motor pick up and start tracking. So I'm not sure exactly what went on that it didn't do it when I tested yesterday repeatedly. But now we have the loose nut out of the way. And, oops, there it goes. Okay. For a second there, I thought that we were moving in the same direction for both the up and down buttons. Not exactly high speed on the max, but there is an adjustment there. And as I recall from Chad's posts, oh, no. What's going on here? Okay, I'm going to have to play this video back, but I'm pretty sure. Totally sure what's going on there. Okay, and this, of course, has been the main culprit. It's not having any trouble driving. But we are hearing a certain amount of gear chatter or something there. I may actually up the tension a little bit. Okay, now I have to get to work, but this at least means that this evening, hopefully I can come back and finish putting this together and get something done. So there we are. Alexa, turn off the telescopes. And I'll finish putting this back together this evening, and we will go from there. The other challenge I do have, and the question will be if I have to pull the board to program it. I swapped this over, got the Wi-Fi chip connected, which if you look in here what we have, let's unplug it just for safety. So whatever reason, maybe they're using Bluetooth on one. So normally the ESP32 has Wi-Fi on it. So this, unless this is the Bluetooth, this may be added Bluetooth. So this may be the Wi-Fi on the ESP32 directly, which would make more sense. And there's the board for that. So this is probably Bluetooth. I'll have to double check those parts. But I changed the Wi-Fi setting, and it shows up on my network, but I can't talk to it. So I can see its IP address, it's got the right MAC address, or it shows up on the DHCP server as having an IP address. I try to, I can ping the IP address and it works, but if I try to actually get to a web page on it, I get nothing. So I don't know what that's about, and of course in the process of switching it over to station mode, lose the AP mode, and there are checkboxes like maybe it can do both simultaneously, but I currently have it only in station mode. I probably should have not changed that when I was trying to get online. Okay, I searched this floor everywhere. Now I dropped that screw for the second or third time now, trying to get it back into this spot, get the circuit board in the right place. And I go down to pick this up, and what do I find but the other missing screw that I searched this entire floor for. That can't possibly have been there, but somehow I missed it. It may have been up here and just fallen down, but I had looked on this stuff, looked in the crevices and stuff, but at least now I know where it's at. So either that or I dropped another one somewhere. All right, so I finally have that screw back in to hold the circuit board in place with this properly extended out through the socket and stuff. That was a little more challenging than I might have expected to get that all lined up. And you may be able to hear my cows bellowing that they want me to give them some feed, but they're just going to have to wait. Okay, so now I can go ahead and close this box back up. I was going to comment, the one downside of stainless screws is you can't use a magnetic screwdriver to hold it in place while you're plugging this stuff in. So that's why I kept dropping it, because it's a very bad angle. If I had a pair of tweezers over here, I could have done it pretty easily, but getting tired of running back to the house or the shop to get different tools. All right, so now with all 6 screws put back into place, this is all buttoned up nicely again. The one thing I'm seeing here is his 12 to 19 volt DC. Now, the battery replacement supply that I use does about 14 or so anyway. What I'd like to know is what the peak current he's drawing is. I may set up a rig so I can just measure that myself. Higher voltage would reduce the total current anyway. We'll see how it performs. If I see some deficiencies, I may look at a different power supply to let me get closer to that 19 volts, since that would actually do a better job in terms of driving those steppers. but we're ready. The other thing that I did is I went ahead and I disconnected these, and I brought this cable around behind the RA cable. So the RA connection, this will never move, but this is going to swing back and forth. And it was the way it was hanging out here in front, I was afraid it's going to get bound up in the counterweights and stuff. So this will let me, I can actually kind of pull this back and keep it back here, and that will make this ride up on that side of that cable. So with that, we're ready to do a few tests and just confirm that things are still operational. I did have to unplug the hand controller, so we've got to plug that back in. Okay. Alexa, turn on the telescopes. And here we go. With the hand controller booted up. Okay, connected, okay. Now, like I confirmed this morning, you do have to go in and start this tracking. Now again, last night I had done that. I'd also tried playing with the parking setting, and neither one made any difference in terms of getting things to move. So, tracking on, side reel, value set, and when we're tracking, it goes to stop if I wanted to stop tracking. So that should all be correct. And we should be able to come over here and see that moving just barely. So we are tracking. And more importantly, if I come and push one of the motion buttons, whoops, got to get all the way out of the menu. Okay, now push one of the motion buttons. Let's see, it's up because it keeps defaulting to a low guide speed. There we go. Max 1x. I want to see if I can change that probably, but here we are at the current max slew speed. So not nearly as fast as Celestron would run, but at least at the moment it's smooth. Now the next test I'm going to do here is go ahead and put my clamps back in to the RA axis and put one counterweight on so that I can run this out of balance and just confirm that I can still move and that I don't get that shaking on the gear. But if we come up here, sorry, it's not focusing well on the gears themselves. But if I pull back, you can obviously see that the positioner's moving. Now, earlier, I thought I saw something that confused me, and did get a response back from Chad when I sent him the pictures of some of this stuff, that apparently there is a glitch or something in OnStep when you're near essentially polar north, and that makes sense. When I wrote my stuff for the Celestron, I had a similar situation where, you know, there's an ambiguity to the spherical coordinate system, and once you go from one side to the other, things flip. And so this may just have been that because I'm so close to essentially being at the zero, I started at zero, and that's probably why. So if I were to power this off, I've moved off of 0, but if I left this at 0, I bet you I'd see that problem. So that may be something that could be considered a bug in OnStep and can be fixed, and I might actually take a look at it if it causes me any trouble, but that's one of the advantages of open source. Other people can work on it. With this, I think at this point I might as well close up the top. There's no reason to get in here. I don't see any reason to adjust anything. I still want to decide if I like my RA adjustment here or not before I close this completely. So let me do a little bit of cosmetics here and we'll test some more. So the one thing I thought I'd point out as I went to close this up, so first off, he's got the screws already inserted in the lid so that you've got the right dimensions, but he's used brass inserts here, so as opposed to going with just like plastic thread forming screws or whatever, he has to put inserts in, and then of course the two connections here will go into the existing scope mount. Okay, so trying to put this on, here's one of the downsides of 3D printed parts, and hopefully I will not have to be taking this off very often, but I started by attaching back here, and the one thing that I found very quickly was that this had to be bottomed out almost completely before it caught the insert. So these screws may be a little short for their purpose. But I had gone ahead and I got these two back screws in, and when I went to try to line this up, it was nowhere near where the holes were. So I loosened the screws on the body, hoping, well, maybe just a little adjustment. No such luck. So I finally took those screws out and was able to get these screws to line up and go into their holes in the actual telescope body, the mount body. Now, of course, this is sagging a little bit just because of the cable weight, but not much. So you can see just how distorted the box is relative to where the lid is and where the holes are. So I'm going to leave everything loose and work on getting these lined up, getting the screws in place, and hopefully I can get this box closed. All right, so there's a couple of issues here after tightening on this. You can see that there's actually a gap between the plate and the mount, and it would be good to have like a washer or something in there. This was already bowing before I tightened this as far as it is, but I'm going to back this off just a little bit. But I had also tightened this down until I basically broke the ball end off of this as I was tightening it, but it's not completely cinched down. I can't 100% tell that it even caught the fitting, or I'm just bottomed out in the screw hole. And if we come over here, you can see the same sort of thing I'm talking about, but at least this time it's pulled down at the back. As you can see, it's kind of bowing where I've got this thing tightened down. And I don't really want to leave it loose, but we will see. I'm saying that a lot on this for some reason. So, time to go get another set of Allen wrenches since I just broke the brand new set that I used to start this. Okay, so backing that screw out, it had obviously missed the fitting inside. Again, all of this bow. We'll see if I now try to tighten it up, whether it'll go in, because it was essentially just screwing into the plastic here, and that was causing it to push this up. So that looks a lot better without that, but I'd like to get the screw in. So worst case, I'll open it up and open that hole up a little bit so that it can go in and have some room to wobble. which is what you would normally have on a screw. I like that he's putting the screws in and using the plastic to hold them, but at the same time, it's got its downsides. And tighten it down the second time. As I started going in, I got a little pop as it seated itself in the insert, and then it pulled up nicely. And now that I've tightened all of the screws, it's actually pretty solid. So, you know, it'd be great to have a nice milled and molded aluminum box and stuff like you had from Celestron. They still had a plastic cover. But, hey, it looks nice. And, you know, people who compared a normal one and this won't really notice the difference for the most part without really knowing their telescopes. All right, so time to put a little bit of weight on this just to see whether or not I have trouble driving with the tension here and the weight offset, and whether or not I get any of that forward and backward chattering that I've had in the past. All right, we'll see if any of y'all were paying better attention than I was when I did this. Of course, in my defense, I slept since the last time I looked at the instructions. But the one thing I forgot is that the cover for the RA axis that has two switches, and so it's slightly taller than the cover for the deck axis. And I had a 50-50 chance of getting it right, and of course my luck went as usual and I lost. And the good news is this was a heck of a lot easier. Now, it may have been a little closer to square, but doing this the second time and starting from here and just working my way out went much easier in terms of putting the screws back in. So, as usual, I tend to do things 2 or 3 times sometimes when I'm doing stuff like this. And at the end of the day, it comes out okay. All right, just to test, I started with this right up at the end, and you can see I think it's actually the joint is slipping there because I've only got 2 screws in, so it's actually sagging a little bit. But I just wanted to confirm, so I pulled it out. I haven't gone all the way to the end, but it has no trouble moving. Whoops, now we're at the limit. But I'm relatively pleased with that. That's a lot of offset load. All right, so I'm just about done and ready to close this up, but I do have these 4 little 3D printed plates, 2 different sizes, that nothing in the instruction sheet he provides shows anything about them or where they would go. I don't recall seeing them in any of the videos that I watched. Looking around at places where they might insert, I don't see any place they would go unless, nope, didn't fit there. I was like, well, maybe it was something while you're installing. It was a guide or something. So I have no idea what these are for. They don't seem to matter to anything that I've done here that I can tell. I certainly hope I don't have to go ripping things apart to put these somewhere, but I can't fathom where they would go. So, unknown bits of plastic. Like I say, the only thing I was thinking initially was, well, were they designed to go in here and kind of block the cables from getting up into the mechanism or something, which, you know, there's never been anything to block that before, and they don't fit, so. And one last look with all the cables neatly tucked into place in the RA box before I close it up. The one interesting thing, because when I opened the stepper boxes, I was like, wow, that looks weird. I've never seen stepper online or anybody do something like this with their stepper. But I realized after I plugged this together, I never mentioned it, but basically this is Chad's connector that he added. The steppers usually will come just with bare wires or whatever, so he basically spliced his own cable into that. This is what that looks like. So, all right, time to put in 6 more screws, tighten everything up, and then I can spend time playing with configuring it, but I might as well get my OTA back on and get things balanced and get all of my cables cleaned up and everything. So you'll see me one more time when I get this closed, and then we'll segue to finishing the whole thing. All right, so now everything's buttoned up, and this gave me, again, a lot more difficulty, so I think this lid may just be a little warped. So even starting here, it just took a lot to get this stuff put in. And, of course, wasn't sure if he realized he's got his label upside down. Put them on the same way on both, but in this orientation, that will always be upside down. Okay, so with that, here's the collection of leftover parts. We've got the 2 short screws that would have gone into those unused slots, and the 1 drop screw that I finally found on the floor, which I'm not exactly sure where I got the replacement, because I brought over my other screws, but then I may have mixed it up and actually ended up, that's where I got the extra, because I thought I had more than that. These, I was like, motor box, where do these go? These look like, now that I compare them, they're the same thread pitch as the black screws that were used to hold the boxes on the Celestron originally. And in my case, I prefer having the black, even though half of these are starting to rust at this point. If I ever decide to swap, I could. So, with that, it's time to get some equipment mounted up, finish cleaning off some of the dust off of the mount, and we'll go from there. So, with that, it's time to get all of my OTA and counterweights mounted up and redo all the cabling. Of course, in the process, before I finish cleaning off the dust out of the crevices and crannies of the mount, and maybe we'll do some imaging tonight. Wouldn't that be lovely? All right, well, I have my mount about as clean as I can get it, getting all the dust off inside, and in the process, I figured out what these things were intended for. Would have kind of expected screws or something for them, but they're basically, if you really wanted to go, you'd have to take all the electronics out. I don't think you just stick these over. But if you wanted to take all the guts out of your center column, then these are covers for the hole to leave them blank. And, okay, that's neat. I'm not going to fool with it. That's a lot of work. The one thing I will say is that, especially given the size of this, what I would have loved was an option, didn't have to be standard, but the option to say, okay, first off, I'd like to keep this switch, but, you know, could have pretty easily come in and had everything that you needed to get to stick out through here in terms of getting the RF out of the metal column. You can't put everything inside completely. It'll still get out through the plastic, but you really don't want it that contained. But yeah, and you know, this could be a project for me in the future. It wouldn't be hard at all to take basically the components on that panel, and as they're spaced now, they're a little big to go here, but they could come through that slot easily enough. And could put this all inside. The reality is I have so many projects I don't need to do that, and this will do fine. But it would be a neat option, especially if you were somebody with a CGE Pro that you still wanted to take it out in the field and you were going to be moving it around. Having all of the electronics inside the box would be kind of nice. So that's what those panels are, though. So mystery solved, but I ain't going to use them. Okay, so with my OTA back mounted roughly where I had it before, which is about an inch or so forward of the back of the rail. This is basically balanced. Okay, so there's no real load one way or the other on the RA. Now, I don't have the piggyback on, but all of the weight on that is the camera back here. The weight here is this doggone focal reducer, and then the camera, which this thing I never use. It's a piece of junk, but I keep trying. I tried while I had while my other camera was dead, and this thing has so much read noise, or actually it's not necessarily read noise, it's just amp glow. And so the amp glow is a problem, but anyway, so that's mounted up. I'm going to see about fixing my piggyback up here as well and get all the cables routed to all the different pieces and wipe a little dust off that wheel. And while we're going through all of this, I figured, what the heck, I'll show this. This was actually probably one of my earliest 3D printed projects for the telescope, and I did a certain amount of welding to put pieces together, I think, on this, but part of this was to get stuff out of the way too after I made it, because parts didn't quite fit the way I wanted. But this was the original focuser, and of course I pulled this off once I stuck the Crayford on here. This is still longer than I want. It just, I can barely get to focus with this stack up, and the results were coming out pretty good. Reality is, if this mount works like I'm hoping, I'll probably dump the reducer anyway, go back to putting everything on the back of the scope, and try some nice high resolution imaging. My skies are never that good though, so I don't know, we'll see. It's just everywhere I look I see dust, or at least what looks like dust. So yeah, that was a very early, old printer, old everything, nasty looking, but hey, it worked, and it worked well. This is kind of what I've graduated to these days. Same stepper driver. What I've done is, of course, this had the thing in the housing. I've gone to making this little module that just has a Arduino Nano in it with the driver board for the motor. So those two are connected together, piggybacked in there, and then I actually drive it with 12 volt power so that it's got more voltage for the motor, and then it just steps down to drive the Arduino. Actually, the Arduino runs off the USB port. Okay, so it's time to get this thing put back together. As you may recall, and I will may or may not put this in the CGEM rebuild, or CGE Pro rebuild, but my little Losmandy clamp part snapped off, and as you can see, when I printed this, I obviously had way too low of infill. But the other part of the problem here is that the way this is printed sitting up like this, and so it's actually, the layers are this way, and that's the weakest spot. So I printed this with a much higher infill so that there is more structure in there. It's got, compared to this doesn't even look like the 15% that I've been printing, so I have no idea which printer, what settings I used when I did that. But that looks pretty horrible. I'm pretty sure this piece is printed the same way. The difference is this is printed from end to end, so all the structure is across this way. So I'm not really worried about this. I'll probably reprint it anyway just to be safe. But I'm not really worried about this fracturing like this part did. And I think this replacement will work just fine. The other thing, this Astrotech AT80 LE, the limited edition they did back when, with the carbon fiber. I love this telescope. Unfortunately, the focuser shot. And if I have the knob loose, you can probably see that it wobbles up and down. Certainly when there's a camera loaded on there and this has any extension, I can't drive it because it's got the focuser motor on the far side, like the same design. So until I do something, I asked Astrotech about actually rebuilding this, and they're pretty much just buy a new one, but I'll lose the Astrotech logo. Or actually, I guess I should say I asked Astronomics about it, but anyway. All right, so when I started putting the Piggyback on, I was still way too forward heavy, and I tried moving this back, but I'm like, okay, I don't know how much I would pick up of like reflections off of this. Don't know how much reflection I would pick up off of this, so I decided let's move it forward and just move the whole thing back, and basically it's almost right to the end of the Losmandy rail. So that's actually nice because now we're getting full clamping all the way across. And as you can see, we are very well balanced. Doesn't want to go anywhere there. And if I bring this over and clamp down and take this off, I am just ever so slightly bottom heavy with the counterweights. And compared to the having a single weight out here with nothing else on it, this is balanced. So I don't have any trouble or any concerns about it moving. And hopefully I've got the RA gear, worm gear tight enough that it's not going to try to chatter or do anything going forward versus reverse. So with that, now let's just get all my cabling on and fire it up and see what happens. I do have one thing I think I'm going to do. So I actually have been having trouble. I can get this thing connected to my network, but on DHCP, I can see it, I can ping it, but I can't get its web page to come up. But what I kind of decided is, well, that's may not be the best solution anyway, since I really only need this thing. Of course, now I got it on the wrong side, probably, but I really just need that box talking to this box. And since I'm using a network cable, an Ethernet cable, to connect this to my network, this has Wi-Fi in it that I can use to connect directly to that, have it on its own subnet. The only traffic is between this and the box, and hopefully that will give me very stable control. We will have to hook it all up and see how that works, but I kind of am excited about that idea. So with that, on to cabling. Figure I might as well catch the process as I go through it. So I've got this adjusted now where pretty much I can come almost completely to the south. I realize you can't see the OTA with this thing zoomed in. If I could do this, I'm going to lose the light. Actually, it just won't let me go to further back than that. Okay, anyway, so that's the cable. Still have to watch if I really try to go that far south, because that's pushing it. And of course, you got the same thing on the other side with the risk. So ideally, I need something to kind of keep it out there, because these things can catch. And all the way back there. But under normal circumstances, it's fine. This thing stays out of the way. But this is power for a bunch of stuff, and then the one Ethernet cable at this point. I took all of the USB cables out. Used to have USB primarily going down to control the mount, but then I also had put a little hub out here. So, network and power, computers fired up. The external hard drive that had just been flopping around out here for a long time. I used some of that magic tape and stuck it up here. Seems like a good spot for it. And now I need to come back and see if I can get my mounts to stick on the Velcro. That's all kind of the button style stuff. And put those back and route to the various cameras and stuff. All right, so here we are, all wired up now. And I played around with the arrangement, but what I had before originally more or less worked the best still, given the cable lengths that I'm working with. But basically, so what I have is I have a USB 3 hub here that has a 5-volt power supply that comes off of the main when I turn on all of the telescopes. That gives 5 volts to turn this USB hub on. I go ahead and I piggyback the USB 2 hub, which runs all of my stepper drives for my focusers, as well as my temperature humidity sensor up here on my OTA. And the steppers also have 12 volts coming into them to give them more drive power. And so this is the low current 12 volt line coming up that also runs the little Tempest fans here. I'm not sure if those do much good versus just pulling dust into my OTA. Then I have the USB 3 going to my guide camera and both of the other cameras. Now the new 268 claims that it will power up all of the USB, reset it all when you power it on, unlike the old ones. So I could and may, depending on throughput issues, I could come straight in and bypass the hub for that camera. But for right now, especially given the cable lengths, I mean, I could put a longer cable to reach it. But for now, that's got me all configured the way I have been. And checking my clamp here, seems to be holding pretty well. Over on the far side, this looks like a crack, but I think it's just a mark from when it was built. And currently, there's no evidence of any defects that I can see on the front. So, for the moment, I think I'm safe with this, but I'm going to keep an eye on it and see. Like I say, I think I'm going to go ahead and reprint that whole bottom piece, and I'm probably going to redesign it to make it longer and to give make this a little thicker. I've got room to do that, and I think I can get away with that. And I think we are ready to fire this sucker up and see if I can log into the computer and get everything talking to each other. And it's well after dark. Question is, am I up to trying to start an imaging session or just ready to go to bed? All right, so here we are on day number 3 of my rebuild. I finally gave up last night trying to get things online when I remotely logged into my little mini PC up here and decided what I was going to do was use Wi-Fi to communicate to the OnStep and use the Ethernet to communicate back. And as soon as I turned the Wi-Fi to connect to the OnStep, I lost communication. I'm like, what the heck? Turns out that my Ethernet port's bad on this guy. And looking up, it seems like there are other people who've reported similar things at the B-Link Ethernet port dying. So I ended up this morning sticking in another USB to Wi-Fi because I couldn't find handy USB to Ethernet. I probably have one somewhere. And was like, okay, I'll keep the normal Wi-Fi on this and I'll use this to communicate. Windows didn't like that because there apparently wasn't getting DHCP from this. But I did get it to connect, but I could barely get it to bring up a web page and it kept timing out on me. So I'm still having trouble getting a web page off of this thing. And there is shadowing, you know, if you think about it, the Wi-Fi antenna is in here. This is a metal box. The OTA's metal. So, you know, I don't have a huge amount of reflectors in the chamber to bounce the Wi-Fi around. So, yeah, it's probably not the greatest link from there to there, but it should be working. You know, I generally don't have any trouble talking to this laptop from over off to the side with the router, but anyway, I've decided, just to save myself the headaches, that it's time to put in one more cable back into all the stuff and run USB over to the OnStep. I mean, that's the most basic. It's just a serial link, essentially, by the time it's done, a virtual COM port. But that should be stable. That gets me away from all these other things. And over time, if I have time, I'll play around with getting the Wi-Fi server. I did try Bluetooth and was able to connect to the Bluetooth, but then it said it was disconnected, and I don't know, even so, if the virtual Bluetooth COM port, if that would work or not. So I think I'm just going to cut my losses and start with USB and work back. And the other reason, of course, that I didn't get started, and I'm going to go through one by one and hook these back up, I had all of my cameras, all of my COM ports in the Windows control panel. I used the friendly name in the registry so that I know exactly what each device is, and if there's something offline, I know which one it is, so I know, you know, which stepper COM port this is by name. And so I've got to redo all that, because as soon as I change the orientation of which things there are, these all get new IDs based on the address of, well, it's plugged into this port and then it's plugged into that port, and it just stacks up the ports that you have. And as soon as you change those ports, all the friendly names that you had go away because they're tied to the port, not to the actual device. So I am going to spend time doing that. Right now we've got some pretty good sized clouds outside, but it's not solid, so it may blow away by the time it gets dark. And of course, at the same time, Borderlands released late last night. I didn't actually fire it up then, but I've got a bunch of Borderlands to go play now that Borderlands 4 just came out. And I bought the Super Duper Deluxe Edition, whatever it's called. But I really do want to get this thing running. So come back and we'll see what happens. Well, here's a gotcha after plugging the USB cable in, and I don't like this because it means I can't reset the OnStep. But because this plugs into the ESP32 essentially, and it's getting 5-volt USB power from the USB port instead of from the mains coming in the other way. So I think what I'm going to have to do, I don't know, I won't get USB 3 speeds, but that shouldn't matter. I'm out of ports on this, but I do still have one port left on the USB 2 up here. And I think the best solution is to go ahead and plug it into the USB 2 so that it only comes on, the USB power comes on at the same time the power to the mount comes on, and the thing's not sitting there running all the time like this computer is on all the time, but that's the only thing that's on, because that then lets me turn on everything else. So I'm working on getting all of my camera equipment and telescope controls set back up after redesigning everything. And basically what happens is that when you move USB ports around, things get reset, and the information about them is all hidden down in the device description with all of these hardware ID information that really shows essentially where the thing is plugged in. So this is the vendor ID information here. There's other stuff, and there's a way to fix this, which is to put a friendly name in the registry. But it's actually a bit complicated because you have to come find your device, go through that list I was showing, find the ID, search the registry, find the ID. And I did a quick search to say, okay, is there a tool to automate this? Because I know enough people are doing it. And while it's not there completely, there is this USB device viewer from Nearsoft who makes Blue Screen View and some other really, really useful low-level tools. And so what this thing does, the first thing I'll say is you've got to run it as administrator in order for this to work, because you need the registry to come up in admin mode so that you can change it. So you start up USB device view, and it will show the things that are there. And so right now I have the generic super speed USB hub and generic USB hub here that are the USB 3 hub, where I have the ability to turn it on and off with the telescope power supply. I also have something that you'll notice is labeled Titan 178U. So that's the internal name that QHY has put on that camera. But the problem is that it comes up as QHY 53 series IO. Everything comes up in the control panel as QHY 53 series IO. Now, I have already gone in and renamed this as QHY 53178M, as well as coming down here and renaming that USB hub to be my camera USB hub that has all 3 cameras plugged into it. And so my guider camera, I could probably extend that and say guide camera, but I know what it is. What I want to do now is, okay, internally this thing's identified. Unfortunately, the control panel doesn't show it. And so all I have to do is I come in here and it says open in regedit. And what that's going to do is take me directly to that key. So they're looking up all the vendor ID information, and you can see, well, the device description is QHY 53 series IO. I could potentially change that, but it will probably screw things up. So the correct way of handling it is to come in here and say new string value and say friendly name. All one word, 2 caps. Now you have the key, you double click on the key and you say, okay, this is my very lousy QHY 183C. And I hit OK, and I can close the registry because I'll reopen it from this. Nothing happens here, nothing happens here. But if I now come in and say scan for hardware changes, that will reload this list, and lo and behold, I have the QHY183C. Now there are these hidden firmware drivers that I'm showing hidden stuff. Those are there in the background, and I think they may just be part of the boot up process when the thing's first plugged in and turned on. The reality is I don't care about those because I normally won't see them. I'll only see these. And so that's really all there is to it. I'm going to go out and plug in my last camera, then I'm going to start plugging in all my other USB COM ports, basically my Arduinos that control all my stepper motors, and relabel all of them. So I'll have COM3 as my focuser for the SCT. COM4 is the temperature sensor. COM5 is whatever else. And so that's really all there is to it. So I now have all of my devices installed, and as usual, the last thing I plugged in was the OnStep controller, and the Silicon Labs UART comes up as an unrecognized other device. So I ended up having to download. This isn't unusual, although I've seen stuff online saying the 2102 is supposed to be more common than CH340s that are being used, but that has a Windows driver already installed. For some reason, the 2100 series don't ever have it installed, and I have to download them. But anyway, that's the OnStep controller there, and I'm going to rename it, and then I will actually be done and can go finish setting up Nina and be ready once it gets dark. And as luck would have it, this little USB 2.0 adapter that I had, which has blue connectors in it, so does this one. This one's definitely only USB 2, and I believe this one is as well. So both of these weren't as advertised USB 3s, but I don't need them to be. But this one that was a nice, neat, flat, all the connectors were up against the body, failed on me, so swapping it out for the other one that luckily I had. This is the way my luck goes. If I ever win the lottery, run for the hills or run to church and get on your knees and start praying, because the world is a-coming to an end. But at this point, we are configured, and like I say, I just need to go into Nina and update my ASCOM driver settings to the new COM port configs, and when it gets dark, hopefully I'll be ready to run.